Hello and welcome back, everyone. As you can see, today we're going to start one of our two sections on graphing. This is 11.5 quadratic functions and their graphs. So one thing that is different for us online versus in the classroom, of course, unless you are printing out the quizzes and tests, you'll have to sort of make your own. If like me, you didn't have any graph paper at home at the time that this hit. The best method I've found is take a little 6-inch ruler, 12-inch will do. If that doesn't work, pardon me. And I've just been going 2.5 inches each direction from the center point, and then marking every 1/4 inch. That way you get 10 one way, 10 the other way. So you still have a pretty nice, somewhat easy to work with grid. So the basic f of x is x squared. All of the graphs that we'll be doing in this section are going to be sort of based on that one. So 0 squared, remember, is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Square a negative and you get a positive. So -1 squared, -2 squared, -3 squared as well. So we get a reasonably accurate graph just from a ruler and some tick lines. So smooth curve, arrows on the end, since that pattern would continue forever in the up and right direction and the up and left direction. So a little mini review on our chapter 8 work. From this, we'll take a look at maybe g of x is x squared minus, we'll do 5. So remember, outside of parentheses are just controlling then up and down when you're working with a function. So this is saying take all of our points in blue, drop them down 5 units. So you can see my little girl is unhappy about something out there. So here we're down 1, 2, 3, 4, and 5. And down 5, down 5, and down 5. And these points across the way would all be down 5 units as well. So it's as if we picked up the blue graph, didn't change the shape at all, just slid it down 5 units. One more on the same grid. We'll try h of x is, well, let's do x plus 3 quantity squared. Again, our first graph would just be the y equals x squared graph. We always start with that one when we're using shifting. Inside, instead of controlling up and down, remember that controls left and right. And remember, inside works backwards from the way that we sort of think it would. Think of what you would have to plug in for x to get a 0 inside of here, and that gives you a hint as to what direction to go. So if I plug in a -3 for the x, I get a 0 inside, and 0 squared is 0. So this point that was at x equals 0 on the original is at x equals -3 on the shifted one. And if that one shifted left 3, all the rest of these guys will as well. 2, 3 units over for him as well. 1, 2, 3 units left for that point. 1, 2, 3 units to the left for these guys, and 3 units to the left for these as well. So hopefully those first couple were just some simple review problems. We'll do one where we have both of those things going on, and then we'll look at something brand new for this section, compressing and stretching. So again, I like to start with my middle on a nice clean line on the paper and go 2.5 inches each direction. So there's our vertical axis, and then I'll drop my horizontal axis on there as well. About 2.5 inches either way, you'd be able to fit 10 in each direction. So every 1/4 inch. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 up, and then do the same thing down. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 down, and do the same thing across every 1/4 inch. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that way, and on the 1/4 inch, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 that way. Okay, so on this one, our goal is going to be f of x is x minus 6 quantity squared plus 3. So we always start with your basic y equals x squared graph. Make sure you have that labeled. I'm doing this one in blue, so 0 squared is 0, 1 squared is 1, negative 1 squared also 1, 2 squared is 4. Negative 2 quantity squared, also 4, and 3 squared is, of course, 9. Negative 3 quantity squared, also 9. So there's our first stage of the graph. Then we just do our shifting. So each point we have a -6 inside. Remember, inside works backwards. If I plug in a +6, I get a 0 inside. So this is saying go right 6 plus 3 out there. We'll go up 3. So each one in blue is going to go right 6 and up 3. 5, 6 right, and 1, 2, 3 units up. 6 right, 3 up. 6 right, 3 up. 6 right, 1, 2, 3 up, and so on. 6 right, 3 up. 6 right, and 3 up. So there's our new graph, vertex in quadrant 1. So the new stuff, vertical compression and vertical stretching. Vertical stretching and compressing comes from multiplying. Shifting comes from adding and subtracting. If you think back to your order of operations, we always do multiplication before we move on to subtraction or addition. So that's going to be true here when we're working with these graphs where we're looking at a square that has either a shift or a flexion or a stretch. Take care of the multiplying first. So this one, our goal is to get to f of x is 1/2 x plus 3 squared minus 2. All right. So again, I'll start with my midpoint on a nice neat blue line, make my life a little bit easier that way. And there we are, 2.5 inches either way, and marks on the 1/4 inch. And as you can see, it doesn't take too long to do this. That one's going to be a nice big line. Right on down the line every 1/4 inch. Doesn't take up a ton of time there. And then just do the same thing with our horizontal guy. So every 1/4 inch, just a quick little hash mark. So here's our x-axis, our y-axis. This one, as always, is based on if I see an x squared, a y equals x squared graph, that's the first thing that I'll graph. 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. And their partners across the way, -1 quantity squared, -2 quantity squared, -3 quantity squared. Again, we have multiplication versus adding and subtracting. Multiplication is higher up the list. So the second thing that I'm going to graph is y is 1/2 times x squared. Now the idea here is remembering that x squared is the same as our old y. What we'll do is multiply every old y value by 1/2. So 0 squared is still 0, 0 times 1/2 is still 0. So this first point, we'll do these guys with the red dots. Hasn't moved, but this other point that happened when x was 1, 1 squared is 1, 1 times 1/2 is now 1/2. At 2, 2 squared is 4, 4 times 1/2 is 2. So this multiplication by 1/2 is shrinking it down. 3 squared is 9, half of 9 is 4.5. And they're partners across the way. So this was at 1, now it's at 1/2. This was at 4, half of 4 is 2. This was at 9, half of 9 is 4.5. So it's like we took the blue graph and we sat on it. We smushed it down. It's growing more slowly. After that, the shifting works the same way the shifting has always worked. So f of x, half of x plus 3 quantity squared minus 2. So plus 3 inside. Inside, remember, works backwards. So the red points are moving left 3. Minus 2 outside. Red points move down 2. So left 1, 2, 3, and down 1, 2. Left 1, 2, 3, down 1, 2. Left 1, 2, 3, down 1, 2. My apologies. I only went down 1.5. I wanted to go down 2. Left 1, 2, 3, down 1 and 2. So we still have that same compressed shape. We just moved it left and down. Left 1, 2, 3, and down 1, 2. That takes us to the axis. So same thing in this fell here. Left 1, 2, 3, down 1, 2. And left 3 takes us to the y-axis, and down 1, 2. So instead of 4.5, now we're at 2.5. Left 1, 2, 3, down 1, 2. So the same shape as the red graph, that compressed graph, only now we shifted it left and down. We'll do one quick negative sign, and that should be enough to get you started on it. All right, so the next one we'll do f of x is, well, let's do -2 x plus 1 squared plus 2. So on this one, as I'm sort of prepping the graph, hopefully you're kind of thinking about some of the things that are going to be happening. So we're going to start with our basic y equals x squared graph. And then we'll do the coefficient, what multiplying by -2 would be. You may want to make some of your predictions now about what that could entail. And every quarter this way. So not as good as graph paper, but pretty good pandemic equivalent. So here's our x, here's our y, and we're starting as always with our y is x squared. So 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So we're always going to see that as our first graph in section 11.5 and 11.6. The new thing here is the -2. So y is -2 times x squared. You don't need the parentheses. I'm just putting them there for emphasis. Just a reminder to take your old y value, since y is the same as this old x squared, multiply each y value by -2. 0 times anything is still 0. This was at +1. 1 times -2 is -2. So it was up here, now it's down here. 1 times -2, also -2. This guy was at +4, now he's at -8. So 2, 3, 4, 5, 6, 7, and 8. And 2 units out. 2 units this way as well. This was at +9. Now it would be down at -18. That kind of takes us to the far end. I usually go just 10 in each direction, even when we are provided with a nice, neat, pretty graph paper. So after that, we're ready for any of the shifting. So if there's a coefficient here, it's going to be a 3-stage graph. If there's not a coefficient there, just the implied one, it'll be a 2-stage. So y is x squared and the shifting. If anything is out here, we need to do the original, take care of what's out there, then do the shifting last. So an f of x -2 by x plus 1 quantity squared plus 2. So left 1 unit, up 2 units for all of the red points. You're always going based off of the last stage that you did. So left 1, up 2. So there's our new vertex. Left 1, up 2. Left 1, up 2. Left 1, up 2. Left 1, up 2. So here is our finished product. So stretched out, and the negative also flipped it over. So some general properties, some things that you should expect. If it's a negative out here, your graph will open down. Positive, it will open up. If the absolute value is bigger than 1, it'll stretch it. Smaller than 1, it'll compress it. All right, so I'm going to get you some homework problems to try out. And 11.6 is going to be a longer section. There's quite a bit going on in that. So 11.5, they were all over in 11.5. 1 to 17, every other odd. 19 to 23 odd. 25 to 45, every other odd. 55, 61, 73, and 75. you have any questions, please feel free to get in touch with me. Otherwise, I'll see you next time. Stay safe out there.